Alright, so this is our final video for repeated decimals. So the first thing we're going to look at is ordering repeating decimals. So very similar to ordering our finite decimals, except they're going to go on and on forever. So in this first example on the left, I am ordering them still from greatest to least. If you remember from the last couple sections, we would line up the decimals and then look at where the digits started to differ. So I'm going to write these each as without the bar, but their repeated component. It doesn't necessarily matter how many you write out. We can start to fill in as needed. So that's the first one. The next one, I've got 4.39292 and so on. The third one, 4.39999 repeated, and then 4.392 with nothing repeated. Okay, so go in and fill in your zeros or repeated digits as needed, but this last one that I need to fill in, it is 4.392, nothing repeated. So I fill that in with zeros. Now as I'm looking down my columns, I'm looking for where do these digits start to differ? Well, they start to differ in this column right here. And so now I'm just going to compare these numbers to see which one's the greatest all the way down to the least. So I'm going greatest down to the least. So I've got 222, 292, 999, and 200. Yes, those have those little dots on it, but I don't need to compare anymore. It would still be true if I extended them out to multiple digits. So the largest of these is 999. So that's going to be my greatest number. I want to make sure I write it in the original form. So as the 39 with the bar over it. Okay, the next one would be 292 would be the next biggest. So that's going to be 4.392 with the 92 being repeated. The third one is going to be that one on top, 4.39 with the 2 repeated. And then the last greatest or the least is going to be the 4.392. On the other side, we're going backwards. Remember that with negatives, you are flipping. So I'm going from greatest to least, but because they're negatives, they really go in reverse order. I'm going to write these out with the decimals lined up. And so I'm just writing them out as their repeated digits expanded without the bar. I got my digits off. And then the last one. All right, fill in my zeros for this one. Now I'm going for where's the first spot that they differ. And so those are all the same, those are all the same, those are all the same, but in this column is where they differ. So I'm going to put a box around those. Now, yes, I am going from greatest to least. However, because the numbers are negative, they're really going to be opposite. And so I've got just in the boxes 5,765, 7,676, 5,656, and then 5,000. So I am looking for the greatest, but because it's negative, I'm really looking for the smallest. And so the smallest number is going to be 5,000. The next smallest is going to be 5,656. The next smallest, 5,765. and the last smallest 7,676. Make sure when you write these that you write these how they appeared in the question. So the first one you would write as it was up here in the question, and then the next one you would write it with that bar over the 6 and the 5. The next one you would write with the bar over the 7, 6 and the 5, and then the last one you would write like so, and then that would be your final answer. All right, the last thing we're looking at is just a couple of concept questions, and so some concept questions about how many how many rational numbers appear between two different fractions or decimals. So here I've got a number line on the screen, and in this number line the question says how many fractions are between 1/3 and 1/2. And since we're talking about decimals, I went ahead and kind of changed the question that says how many decimals are between 1/3 and 1/2. So I just started listing some. Well, 1/3 is 0.333 repeated, and 1/2 is 0.5. So 0.34 would be between those, 0.35. But between those two, 0.341, 0.342, and so on. So you can see just a glimpse that there is an infinite number of rational numbers between, rational just means fractions, and fractions are decimals. There's an infinite number of rational numbers between any two fractions. Because the number line is infinite, we could look at 1/3 and 1/2. We could look at 0 and 1. Anywhere between there is an infinite number of rationals. So you're going to have a couple of questions on the test and on the homework that asks to list some rational numbers in decimal form between these. And so the first one, it says to find 3 rational numbers in decimal form between 0.67 repeated and 0.673 repeated. I think the easiest way is to write these things out in their repeated form without the bar. And then this one would be 0.673 with the 673 repeated. Now, just like when we were ordering numbers, let's go to where's the first digit that they're different. Well, that third digit. I just need to list any numbers in between, in this case, 6 and 3. And so what about the number 0.674? That's between 3 and 6. What about the number 0.675? That's between there. However, I've got a problem. If I say 0.676, is that smaller than 0.6767? Well, yeah, because that would be a 0, and if I compared those two, 67 is larger than 60. And so these would be my 3 numbers that I could use for answering the question. However, there are infinite, so you could have said 0.6737. That's between there. You could have said 0.6742. There are truly infinite right answers. All right, let's look at the last one. Find 3 rational numbers in decimal form between 1/4 and 0.25 repeated. First thing I need to do is write 1/4 as a decimal. This is probably one you know, but just to remind you, if you need, if it's not one you know, the way that you write these fractions as decimals is you do long division. So you'd say 4 goes into 10 2 times. With my decimal, 2 times 4 is 8. Subtract, carry down a 0. 4 goes into 25 times. Subtract, and then I'm done. So if you didn't know that, We've got between 0.25 and 0.2525 and so on. And so I'm looking for numbers in between those. So look for where is the first digit that they're different. So I'm looking for numbers between 0 and 25. Those would all be between these two decimals on a number line. So my first one, I could do 0.251. I could do 0.252. Now if I say 0.253, that's bigger than this one. So I need something on the other side, on this side of 0.25 repeated on the number line. Well, as long as it's smaller than 25, I'm good. And this one is really 20. So I could say 0.2521 or 0.2522 and so on. But it only asked me for 3. So again, there are infinite right answers, but those 3 would suffice.